All right, this is section 3.4. We are trying to verify properties of quadrilaterals. We talked about quadrilaterals yesterday. We talked about polygons. We talked about quadrilaterals. We talked about parallelograms. We defined all those things in the last lesson. Today, the only new definition that we're looking at, or the new shape that we want to know the definition for, is the rhombus. So the rhombus is a quadrilateral, which is what? What is a quadrilateral again, Jonathan?
With all four sides equal.
No, that's a rhombus, but a quadrilateral is just a
Four sides.
Good. A polygon with four sides. Okay? In which the lengths of all four sides are equal. So, the most famous rhombus has a special name. It's called a square. Good. Yeah, a square. So, all four sides are the same, and they're equal. That's the definition of a square. So, that works. Okay, a rectangle is not a rhombus because a rectangle, all four sides are not equal. However, you can have a parallelogram that is also a rhombus as long as the sides are all equal and the opposing sides are parallel. Okay? So those are two examples of what a rhombus looks like. Okay? The first property we want to verify is one that I mentioned yesterday, and it involves verifying that a parallelogram So we did mention this yesterday. Verify that a parallelogram is formed when the midpoints of any quadrilateral are joined. So when I say any quadrilateral, I just need four sides. So my shapes can be as strange as I like, or as simple as I like. As long as I find the midpoints of each line segment. Oh, this is not a quadrilateral. Oh, it is a quadrilateral. I did that. Very slight angle change there. Okay, as long as I correctly identify the midpoints, and I join them, what I form then on the inside of that quadrilateral, in every case, is a parallelogram. Okay, and you can see that, I think, accurately enough with these strange quadrilaterals. You can see even no matter how strange they are, you still end up with a parallelogram on the inside. Okay, in order to verify this, tell me what we would do if we only had the points of the vertices. Tell me what we would do, Steven.
Find the midpoints of every line, and then you would find the slope of each line.
Okay.
And then the lines between the midpoints, and then you would have to check if they were parallel or not.
Okay, how would you find the slope? You get the midpoint, okay, that's fine, that's easy enough, we use the midpoint formula. How would you find the slope of the line?
You have to check the slope between that midpoint and the next midpoint.
Good, so you check these 2 points, and then with those 2 points you could find the slope. Okay, and then you do the exact same thing for the other side, check that these two slopes are the same, and then you know the lines are parallel. Okay, then you do the same thing on the other side. You find this midpoint, check the slope. Is the slope the same as this slope? Yes, it is. These two lines are parallel. What if I wanted to check that it was a rhombus? Ace. So rhombus, ace up here, it's a quadrilateral in which the lengths of all four sides are equal.
So you find the length of each line and make sure they're equal.
Right, so you're just going to check the lengths of each one of these side lengths. Yeah, and we do that using the length formula. Okay, that we all have memorized. Who knows the length formula off by heart? I hope. Everybody? Yes? Kyle?
AB equals square root of x2 minus x1 squared plus y2 minus y1 squared.
Excellent, good. Plus. Sometimes you get confused with the plus and minus in the middle, but that's correct. Plus. Good. So we can go through that whole proof. You can see it's on page 140 of your textbook. Okay, the first thing they're doing is identifying the midpoints with the midpoint formula. The next thing they're doing is finding the slopes and ensuring that they're the same. Okay, I'm not going to bother rewriting all that on the board. You can see it very clearly and simply on page 140. Page 141, the next one we want to look at. Verify a quadrilateral verify that a quadrilateral is a rhombus. So this is on page 141. Okay, so we already spoke about this actually in this example. Ace told us if we wanted to verify that it was a quadrilateral, we would just use our length formula from the actual midpoints and then find out the length of each one. If they're all the same, then we know it's a rhombus. Okay, again, a very long solution there, but the only key is just to know the length formula. Okay, we'll do this one. Let's look at B actually. So the first one, A, verify, use the length formula and check that all four sides are the same. And then B says, verify that the diagonals of PQRS bisect each other at right angles. So tell us what we would need to do here. So I'm going to draw this out. Okay, so there's our quadrilateral. We verified that it's a rhombus because we learned that all four sides have a length of root 13. Now the question reads, we want to verify that the diagonals, so now the diagonals, remember, they run across the inside of the shape, diagonally across. We want to ensure that these diagonals are bisecting each other. So we remember what bisect means? Davide?
When a line goes through another one.
When a line crosses, not just crosses another line?
At a midpoint.
At a midpoint, okay? In other words, it separates the line into two equal parts, okay? So what they're asking us then is if these two lengths are the same and these two lengths are the same, okay? All right, so how would we do that? Yeah, John Luca?
You have to find the lengths of the diagonals first,
Okay,
and then to get the midpoint, you can find the slopes of both of them, set them equal to each other.
okay, yeah, so system of equations, elimination.
And then once you get that midpoint, then you check the length of the midpoint and one point to check the length, see if it's, and then you can check the other lengths to see if they're.
Right, so once you have this midpoint, or this intersection point, let's call it, you can use the length formula, check this length, and ensure that they're the same length. And then you know that this line is bisected. Likewise, you could do the same thing on the other side. In the textbook, they say the diagonals have the same midpoint, they bisect each other. So they actually did a method that was mentioned yesterday. Who was it brought this up? One of you guys said, it was Steven. He said, what if I just check the midpoint for each line? And if it's the same point, then I know they bisect each other. It's excellent. So you could do it that way as well. Okay, so what they did then is check the midpoint, use the midpoint formula for this line, found out the coordinate of I, which was 3, 1. Okay, and we can do that midpoint of PR. Okay, we're looking for the midpoint here, and we find out that it is 3, 1. So that is the midpoint of PR. So PR, that's that midpoint, is 3, 1. Now we want to look for the midpoint of QS. And it's also 3, 1. So that is probably a faster method, I would say, than finding the intersection point, which takes a bit of effort, because you need to do the system of equations or substitution, and then checking in the individual lengths. So this is definitely a much quicker way to do it. Okay, so I like that method. All right, that's it for 3.4. Any questions?